So in the previous class, if you remember, we discussed some of the things about transport layer. Okay, so just to recap, um, we have considered like what kind of services it provides, like how it is different from network layer. Okay, uh, and what is process to process delivery, and we have seen the concept of port numbers. So far we had things like IP address and MAC address, etc. And what is this port address? That part we have seen. Then we have seen about port addresses, how the numbers are given. Again, what are the types? Like we have some well-known ports and registered ports and dynamic ports, and what is socket, and how it is linked to IP and port addresses, and what is multiplexing, demultiplexing, and how error control when I consider in data link layer uh, is different from the error control in transport layer. These are the things we have seen in the previous class. Next thing is like when I consider this transport layer, basically the layer which is just below application layer, we can consider like you are going to have three different protocols, that is SCTP, TCP, and UDP. These are the three different protocols we are going to have here. Like as you can see here, the location. Okay, location is exactly here, like below application layer. We are going to have these three layers. Then, when I consider UDP, UDP stands for User Datagram Protocol. This User Datagram Protocol, we can also say it as connectionless protocol, because, for example, if you are trying to send any data, or you want to send some data, you are not going to establish any connection over here. Okay, you are not going to establish any connection from source to destination, and directly you are going to send this particular data. That is what you are going to have in UDP. Like if I consider TCP, that will be connection oriented, because you will have to establish a connection before you can actually send any data. And like if you remember our CN lab, again we did like some of the batches did experimentation on UDP and TCP, where they found like if you are considering TCP, you are going to have acknowledgement. Like if I have acknowledgement, I can say like that is reliable, because if someone is not getting anything, then I will come to know by looking at acknowledgement. But when I consider TCP, I do not have any measures using which I will be able to find out if the other person has received something or he did not receive. That information is not available if you go with the UDP. Like when I say like this is connectionless and this is unreliable, what extra thing we have with this one when I compare with IP? That is the question we will be getting. Okay, it's like even when I consider IP internet protocol, that is also giving us unreliable communication, and also it is also connectionless service. So how it is different from IP? That is a question we will be getting. So to understand that, first we need to look at this point. Like UDP provides process-to-process communication, but when I consider IP, it is providing us host-to-host communication. Okay, that is one thing. Except from that, is there anything that is making us move towards this one? Is like there may be some cases or some applications where I just want to have communication. That's it. Okay, like I do not want to establish a connection. I do not want to maintain the connection and terminate, but I just want to transmit small amount of data. Okay, so whenever you have requirements like that, then UDP is useful to use. Okay, so we will see here what are the well-known ports we have in UDP. and what is user datagram, checksum, UDP operation, and what are the uses we have with this one. These are the things we will be looking. So these are some of the port addresses, well-known port addresses which are used with UDP. Like you can see, echo is there, discard, users, daytime. Okay, these are some of the things which are used. Like with respect to examination, uh, I feel like you don't have to remember all these things because it will be very difficult to remember these port numbers and replicate the same thing in exam. But you just have some idea like we have some port addresses which are well known even with respect to UDP. Okay, and out of this, we do have some of the important things like TFTP 69 and SNMP protocol 161 and SNMP draft message 162. Okay, these are some of the things which are very useful. And for example, in my system, I want to know what are the well-known ports I have, or specifically, if I have to look at the port addresses which we can use if we are using FTP, then I need to give this particular command. Basically, all these port addresses are available in the directory etc services, and specifically, if I am looking at FTP, then I need to give this command and I'll be getting like if you are using TCP, the port address is 21, and if you are using UDP, then also the port address which you have to use is 21. That means there are some port addresses which are common, either you use UDP or TCP. Then we have SNMP. See, similarly, if I have to look for SNMP and corresponding port addresses, I can specify SNMP slash etc slash services. And like SNMP with TCP, we will be using this. SNMP with UDP, will be using this. These two are with respect to network management. And if we are using any traps, like trap kind of information, then we will be going with the SNMP trap, that is 162 port number. Okay, again, like I cannot exactly say whether you will be getting these kind of things in exam or not, but what I can say is these are things which are not so important. Okay, it's okay if you learn these things, but with respect to exam point of view, maybe I can say like they're not of that much important. Okay, and this is very important, like format of user datagram. We are going to have a simple format for user datagram. First 16 bits you are going to have source port number, and next 16 bits you are going to have destination port number. Then I have total length field and I have a checksum. Okay, so can anyone say like why do I have to go with checksum here? Already we had checksum calculation in internet layer, right, or network layer? Yes, can anyone say yes something?
In transport layer also we have error control, sir.
Yeah, in transport layer also we have error control, but when I have checksum calculation available at network layer, why do I have to go again here? Okay, we will see soon like why we are considering this checksum again when we actually get into calculation of this checksum thing. Okay, now let us focus on the other parts. Like source port number is like the process which is trying to establish a communication or wants to communicate with other one. That port address we are going to give here. Like from my system, HTTP is sending a request to some destination. Then source port address will be my HTTP port number, that is 80. Similarly, destination port number, like this process, the process which is there in my system, if it is communicating with some process with port number, maybe I can say 80, it may be 80 if you are communicating with HTTP only, or some temporary number like 20,000, 30,000, then I am going to have that number here. And these port numbers, like as we considered in the previous class, it can be varied from 0 to 2 power 16 minus 1, that is 65,531. Okay, then the total length field, again one more thing, like I have this total length calculation in IP also. Again we are considering total length calculation here, because this UDP doesn't want to completely rely on IP, that is internet protocol, to come up with what is the length of its data. What is the length of its data. So what we are doing is we are trying to include total length field here also. By looking at this particular format, uh, like can anyone say what is the maximum data size which I can have? Yes. What is the maximum size of the data I can have? If I give 16 bits per total length. In IP, what is the maximum size of the packet I can have? See, for example, if a bus has 50 seats, how many people can sit? Yes, what happened? I don't know if you are saying any answer, but I cannot hear anything. We are trying to give 16 bits per total length field. So how, like, what will be the maximum size of the data that I can carry?
2 power 16.
2 power 16. Okay, that's fine. Like how we are getting is because 16 bits we are giving, like size we will be mentioning like 1 byte, 2 byte, 3 byte, like that. I can go till 2 power 16 bytes. Okay, or to be specific, it will be like if I am giving numbering from 0, it will be 2 power 16 minus 1. Anyway, 65,535, something like that. Okay, so can I have that much data in UDP? When I have 16 bits here, can I have data size equal to 65,535, or any restrictions I am going to? Any guesses on that? For
Sir,
example, yes.
there might not be any restrictions because all those are required, like all those things which are required are already there in the header.
Now you think like we are having a mandatory 8 bytes. So the data size I can have is 65,536 minus 8. That's what you are saying. Is it correct?
Yes, sir.
Or 65,535 minus 8 to be specific. Okay. So if I consider like that here, when I go to network layer, what is the maximum size I can have there? Think of the total length field. There also we have given 16 bits. So what is the size of data I can have there?
Same, sir.
Same, that is 65,535. So it is something like I have an application, okay, which is generating some data for which at transport layer we are attaching something, okay, and this entire thing becomes data for network layer, and again we are attaching some header to it. We said this entire thing to be 65,535, out of which 20 bytes is mandatory. That means what will be this size? Maximum value. See, again I am repeating, this is application layer, this is transport layer, and next I have network layer. At network layer, the maximum size which is possible including header is 65,535. If I consider header is of size 20, okay, that is the minimum value I can go with. What will be the maximum size of the data that I can carry? That's what I am asking.
65,535 minus 20.
Yeah, so 65,535 minus 20. That means this data is coming from transport layer. So what is the maximum size I can have from transport layer? 65,535. Sorry, 535 minus 20. Whatever 2 power 16 minus 1 minus 20. Okay. Out of which again I am going to have 8 bytes header. Okay. So the overall thing it will be like 65,535 minus 8 minus 20. Okay, 65,535 minus 8 minus the 20, that means 28. So the maximum data size which is possible is 65,507. That is the final answer. Like if you are using UDP, the maximum data size which is possible is 65,507. Do you understand that? Yes.
Sir, how 507, sir?
See, for 507 you add 8 bytes. It will be 515. Again IP header it consumes 20 bytes. So it is 535. So at the IP layer the maximum size possible is 65,535. Out of which 20 bytes is header. Okay. So if I have data itself, this data itself 65,535. For that if I add 8 bytes, it will become 65,543. But I cannot accommodate more than 65,535, right? Similarly at the network layer also, if I have here itself 65,543 and 20 bytes of header is added, then it will become 65,563, which cannot be accommodated in the corresponding header. That is the reason the maximum size which can be added in UDP is 65,507. Is it clear?
Yes, sir.
Yeah. So we talked about source port address, we said about destination port address, then total length, which we said like it is the combination of both header and data, and UDP basically it is not interested in relying on internet protocol or IP and calculating the total length field, because whatever the total length we have in IP layer, from that if I remove header length, that will be same as this total length itself. Okay, but even though I have their flexibility to know what is the UDP size, we are not relying on IP and we are going back to this UDP format itself. Okay, so UDP length I can calculate like this: IP length minus IP headers length. Then I'll get what is the size of UDP length. Then we have something called as pseudo header, which is very crucial in calculation of checksum in UDP. Like the checksum calculation we have done at Ethernet or maybe at IP, you will, I hope you remember, like we did like 16 bits at a time, we considered and added all those things, and at the end we have considered the inversion or the complement value of that particular result. Similarly, here also we will be doing the same thing, but the difference is rather than considering only the header of UDP, we are also considering some pseudo header, which has source IP address, destination IP address, and this protocol field which says like this is related to UDP and it should be 17 only, and you are going to have 16-bit UDP total length, and we are going to have some zeros anyway here. We are going to have some zeros over here. These zeros are useful whenever you are doing encryption. Like if you want to add some padding bits, then these things will be useful. And we have data, and for this data also, like if you want to go with some specific boundary, you will have to add some bits over here. Okay. And here, why do I have to consider pseudo header? For example, if I calculate checksum without this pseudo header, there may be chances like whatever the data we are providing, including source port and destination port addresses and UDP length, everything may be matching, but the IP address may not be matching. In that case, instead of delivering to one particular host, you will end up in delivering to another host. We do not want those kind of things to happen. So to overcome those things, we are trying to consider 32-bit source IP and 32-bit destination IP address in the pseudo header of UDP. Next thing, why do we need 8-bit protocol is like if this particular protocol is there and if I fill that one with 17, then it says like it is related to UDP and it won't give it to TCP. Like that, we have some pseudo header which will be very useful in calculation of checksum. Like whether the concept of pseudo header is clear for you?
Yes, sir.
Okay. So this is one of the most important one. Like they will directly ask you draw the pseudo header of UDP and also explain how checksum is calculated. Okay, in such case you will have to write this particular thing. Okay, then like this is how checksum is calculated. Like earlier also we have seen, right, when we considered IP datagram, then also we have seen like individual this 16 bits at a time we are going to consider, and we will be doing arithmetic addition for those things. The same process we are also doing here, like 153.18 we are trying to represent in binary, here 8 bits, here 8 bits, total 16 bits, and all those values we will be doing addition. After doing addition, the complement value we are going to consider for checksum. While doing these calculations, we are going to consider this checksum field as all zeros. Okay, and we will be calculating. And whenever like you will be like a particular application will be interacting with another application by attaching to a particular port address. So the information whatever you want to send, it's like multiple processes may be trying to send that requests I can say, or commands I can say, to the underlying UDP protocol. So we do have some kind of queues here which can store this particular information. Okay, for incoming and outgoing data, either from application to the destination or the destination process to application process over here. Okay, so that's that particular thing is described in this case. Then that is about UDP. Like UDP, we consider like why do we need UDP? How it is different from IP? Okay, then we have seen like what is the format we have for UDP and pseudo header of UDP and checksum. Okay, any doubts you have in that one?
No, sir.
Okay, next we will consider is TCP. TCP, unlike UDP, it is a connection oriented protocol. That means if I have to do any kind of data transmission, first thing what I should do is establish a connection from source port address to destination port address, and even it has to deal with things like maintaining the particular connection and terminating that particular connection once the communication is over. When I consider UDP, we do not have any mechanism for handling error control. The only possibility we have at UDP is calculation of checksum. Okay. Apart from that, we do not have any measures using which error can be controlled. And flow control, if you are trying to send at a faster rate, then the data will be lost. We do not have any windowing mechanisms or windows protocols which can make sure like your data is safe without overflowing. Okay, that concept is not there in UDP, but TCP allows both the things like flow control and error control. Even along with these things, TCP can also have guaranteed delivery, we can say, or reliable communication, we can say, and also this TCP at the transport layer provides congestion control also. So the next thing, like under TCP, what are the things we are going to cover are the services which TCP provides and the features which TCP has. TCP segment we will be looking, and we will be looking at a TCP connection, how flow control is handled in TCP, how error control is handled in TCP. These are the things we will be looking further. So one thing you need to remember, like many a times when I taught with MTech students and also with BTech students, the basic problem is they get confused with TCP services and features. If a question comes about TCP services, they write TCP features. If you get a question about features, they write about services because they look like same. Okay, we will see and we will try to get some clue on how we can distinguish between these things. Again, like if you remember in UDP also we had these kind of uh, uh, port numbers, like almost all same kind of port numbers, right? Uh, the same thing we do have in uh, TCP also. These well-known port addresses. Stream delivery, like UDP, if you remember, it can be considered as uh, a connectionless service and byte oriented delivery. Like byte by byte we are going to send. Even if you have a bigger message, you cannot carry more than 65,535 bytes in UDP. But when I come to TCP, you can have stream of bytes coming from source to destination. Okay, that is the variation we are going to have when I consider TCP and UDP. Okay, TCP is reliable, UDP is non-reliable, TCP connection oriented, and UDP is connectionless, TCP is stream oriented service, UDP is byte oriented service. When I say stream oriented service, continuous stream of data you can send in TCP. When I say byte oriented, byte by byte we will have to send. We cannot have continuous data transmitted from UDP server to UDP client or client to server. Okay, if you have the data wherein we have to send a stream of bytes from source to destination, in such case each and every byte will be treated independent of previous bytes in the stream. That is the worst case scenario which is possible if you want to have stream of bytes in UDP. Then sending and receiving buffers. In TCP, you are going to have these things. Like I'll have an application which is trying to generate some data. That data we are going to store in some buffers. Okay. And these buffers will be rotating. Like you can see, these gray colored ones are empty ones. Sorry, gray colored ones are the segments for which we got acknowledgement, and white colored ones are the ones which have been sent, but we are yet to receive acknowledgement for them. Okay, once acknowledgement is done, you can remove those things from buffer. Similarly, like these pink shaded things are the bytes which are not sent yet. Okay, we have here the information of like the data which is being sent, the data which is empty, like the buffer space which is empty, and the buffer space in which we have data but we have not sent till now. Okay, so it is starting at this particular position. Starting at this position, I have sent second one and the third one, 4, 5, 6, 7, 8 I have loaded, but I have not transmitted those packets because I need to look at what is the capacity we have at the other side also. So sending process communicates with receiver process or receiving process about what is the memory size which is available, and by looking into that particular memory size and congestion in the network, these processes will look into the information like whether I have to send data now or I should wait. So this entire thing appears to be like stream of bytes flowing from source to destination, because till every like each and every bit of this particular stream is delivered at the other side, we won't be disconnecting this particular connection. Okay, and it's like one-to-one connection is there between present byte and next byte or previous byte. That is the reason we are calling this one as stream of bytes. Okay, then TCP segment. So when I consider TCP segment, like the data stream of bytes, whatever we have continuously, we are not sending as it is, but we are dividing into smaller segments, which are shown over here. Okay, like that we will be sending from TCP server to TCP client, or TCP client to TCP server. The bytes of data being transferred in each connection are numbered by TCP. Like to have proper reliable communication from source to destination, we need some kind of numbering. Okay, for the data which is being transferred. So that numbering is given over here, like some random number will be generated, and using that random number, like we will be assigning that random number for the first connection, and later on like sequence of operations will make that particular number increase further. Okay, overall the bytes of data being transferred in each connection are numbered by TCP. The numbering starts with a randomly generated number from 0 to for example, if I give sequence number till 32 bits, I can go with 0 to 2 power 32 minus 1. If I have this size of the sequence number as 16 bits, in that case I can have anything from 0 to 2 power 16 minus 1. Then you can see here a sequence of sub numbers have been given here, segment 1, 2, 3, 4, 5 and so on. For that we are given with sequence number 10,001, 10,002 and so on till 11,000. For the second segment it is given like 11,001 to 11,001 to 12,000, similarly 12,000 to 13,000, like that. Some sequence numbers have been given to identify each and every segment, because if I just look at the segments without any addressing, then it will be difficult for us to look into that particular segment. That is the reason like each segment is given some initial number like 10,001 and it is going to carry 1000 bytes. After that, next byte will be 11,001. So if you are sending 100 bytes, for each byte we will be giving number, but only for the starting number we will be considering a sequence number. This thing is clear? What is sequence number and what is segment?
Yes, sir.
Yeah. So segment will have multiple bytes, but sequence number will be the starting byte of the segment. Okay, maybe you can note down somewhere. Segment will have multiple bytes, but sequence number is the starting byte of that particular segment. Okay. Then the value in the sequence number field of a segment defines the number of the first data byte contained in that segment. That is what we said, right? So if I consider a particular segment, the sequence number of that particular segment can be found by looking at first data byte in that particular segment. Like if I consider segment 3, we have from 12,001 to 13,000. So segment number, sequence number is 12,001. Similarly, if I have 14,501 to 15,000, in that case segment number 5 will have sequence number 14,501. Okay. Then the value of the acknowledgement field in a segment defines the number of the next byte a party expects to receive. That means, for example, I have sent a packet with sequence number 1. Then receiver replies with acknowledgement and the number in that acknowledgement will be 2, which says I am expecting a packet or a segment with sequence number 2. Okay, so I have sent first one, so the other side it will say like I am expecting number 2. Okay, when I send that number 2, it will say I am expecting number 3. Okay, I'll send number 3, there is no reply. I'll send number 4, then it can cumulatively say like I am expecting 5. By default, when it says I am expecting 5, like it has received 3 and 4. That's the reason we are saying the acknowledgement number is cumulative. Okay, so this is the TCP segment format we have. So before going to TCP segment, like I'll stop the recording and stop.